All right, guys, so we are going to be going through the rest of the word problem section for the math portion for this week, okay, in ACT Prep. So I'm just going to be walking you through the notes, going through the practice problems with you, kind of explaining some things, and then you'll have an assignment to do at the end. So go ahead and open your books, page 286, and we're going to start there. So the first thing they look at is averages, or the mean. Remember that to find the average or to find the mean, you add up your total amount and divide by the number of things. So for number 14 here, it says if Joey buys 3 shirts for $18 each and 2 ties for $12 each, what is the average price of all the items he bought? So we need to go ahead and add up to figure out how much total he spent. So he had 3 shirts times $18 each, plus the 2 ties times the $12 each gives us $78. Okay, so then we just need to take that total of $78 and divide by the number of items, which is 5, and that gives us $15.60. So that is the average, or the mean. Okay, so the answer is J there. In the book, it gives you like a little blurb, and it says that T is equal to A times N. So sometimes it says the ACT will give you the average and the number of things, and then you can find the total using this. Just multiply those two together. So this next problem uses that. It says Heidi has an average score of 78 for her first 6 chemistry tests. If Heidi's scores for the first 4 tests were 82, 78, 87, and 73 respectively, what was her average score for the last 2 tests? So first we want to use that little formula, T equals A times N, to figure out the total number of points. Okay, so they tell us that her average was a 78 and she took 6 tests. So we want to multiply those together to get a total here of 468. All right, so that's like her total for all 6 tests. So then we need to now add up those 4 tests that they gave us. That gives us, let's see here, 320. And then we need to subtract that away from the total. So 468 minus 320 gives us 148. So that is like how many points total she has left, but that's for the last 2 tests. It's asking for the average for those last 2 tests. So then we need to find the average, take that 148 and divide it by 2, which gives us an average of 74. The second thing it talks about is the standard deviation. So mean and standard deviation are grouped together normally. The mean is a measure of the center, where is the middle of some set of data. The standard deviation is a measure of spread. How spread out is a set of data, okay? So it's really, the definition is really kind of like the average distance from the mean. In general, how far away are your values from that middle value? So the more spread out your numbers are, the larger the standard deviation will be. The more closely they're grouped together, you're going to have a smaller standard deviation. So for this problem, it says after finding the mean and standard deviation of a list of these numbers, Aaron adds 4 to each number in the original list, creating a new list. Which of the following will be true of the new list? So if you add 4 to all of these values, and you can do the math to figure all this out, but kind of just think about like if you made a dot plot or a graph for those values, right? So you've got some numbers here, 3, 6, 7, okay, here's your values. I know that's not all of them. But what you're doing basically is taking all of those and adding 4 to it. So this guy's going to get moved over 4. This one will get moved over 4. This one will get moved over 4 units. So that dot plot is going to look exactly the same. It's going to get shifted 4 units to the right. And so the mean is also going to get shifted 4 units to the right because that middle is moving, okay? It's moving up. But the standard deviation, how spread out it is, that is actually not going to change because if you move everything here, right, It gets shifted over 4 units, but it's not going to be more spread out than it was before. So the answer for this one is actually D. The standard deviation of the new list will be equal to the standard deviation of the original list. The next section here is ordering. It says, most of the time ACT will not require you to use the formulas for combinations and permutations, so we're not going to go over them. But you do need to know how to count up the number of orders or the number of arrangements of certain things. So this problem actually comes up a lot. It says a cafeteria offers students a choice of 6 drinks, 3 main courses, and 3 side dishes. How many different lunches consisting of 1 drink, 1 main course, and 1 side dish can the cafeteria prepare? Same type of problem you've probably seen like with outfits. You've got 3 pairs of pants to choose from, 2 shirts, however many shoes. Anytime you see this type of problem, you always want to just multiply, okay? Think multiply all of those numbers of options together. I like to make little like dashes or slots, and I'm going to show you, we'll use this in the next couple of problems too. So the first thing they talk about is the drink. So there are 6 different choices for drinks, okay? You've got a main course, there are 3 options there, and then you choose a side dish, there are 3 options there. So all you need to do is multiply these 3 numbers together, which gives us 54 total combinations, okay? So multiply those together for that type of problem. This one's a little bit different, same idea though. Every morning 5 people line up for the 8:30 bus. In how many different orders can the people in line be arranged? So again, you can kind of think about the situation. Here's the bus, right? And then you've got 5 people, okay, in line. So how many, say we're starting here, how many options do we have? Well, there are 5 people, so one of those 5 has to be there. For second in line, well, this person is already standing here, right? So now I'm down to only 4 options. There's only 4 people left. Next, there are 3, and then 2, and then 1. Again, I am multiplying these together, which gives me 120 different arrangements or different orders for those people standing at the bus. Okay. Now, the next part talks about permutations and combinations, and you can see at the bottom there, that's what's on the side of your book. In general, what you need to remember is that a permutation, the order of the elements matters, but combinations, they do not. So think combinations, you're grouping things, but for permutations, you're ordering things. So when you look at this notation that they're using in the answers here, P stands for permutation, C stands for combination. The number out in front tells you the total number of people that you're choosing from, and then the second number tells you how many you are actually choosing. So in this problem, it says a teacher is selecting a group. So right there with group, that is a clue that you're going to be using combinations because you're grouping people, okay? So we can go ahead and eliminate everything with a permutation. He wants the group to consist of 2 boys and 3 girls. If the teacher's class consists of 13 boys and 14 girls, which of the following creates or represents the number of different groups the teacher could create? So we need to think of these 2 separate because we're choosing boys and girls separately. So for the boys, there are 13 boys, and you're choosing 2 of them. For girls, there are 14 girls, and you are choosing 3 of them. So the answer there is D. Okay. If the question said, how many different ways could I order 2 boys and 3 girls, then it would be this, because the order does matter. If you're just selecting groups, the order does not matter, which is why the correct answer is D there. And then moving on to probability. So we're going to probably be using our same methods here where you have to count up the total number of ways something can happen. But now if it's asking for a probability, it wants the number of ways possible, or the number that you're looking for that you want on the top, over the total, which would be on the bottom. So Cheryl has a jar of marbles. There are 24 white marbles, 10 blue, 6 red, in the jar. What's the probability that Cheryl will not select a blue marble the first time she pulls a marble out of the jar? So we need to basically just count up how many are not blue, that goes on top, out of the total number of marbles. So if you count those up, you should get that 30 of them are not blue out of a total of 40. And then you do go ahead and simplify these when you can. So 3/4, so our answer is E. Next one, Duke has downloaded 4 movies to watch for a weekend movie marathon, and then he lists those 4 movies. He's trying to decide what order to watch them in. What is the probability that he will watch Chucky, Freddy, Jason, and Michael in that order? So we need to count up how many orders are possible, right? Which is kind of what we did earlier. There are 4 movies. So he has 4 options for the first one that he watches, 3 options for the second because he's already watched one of them, and then 2 and then 1. And we multiply across to get a total of 24 options. But then the question is, what's the probability that he's going to watch them in that certain order? There's only one way that he could watch them in that specific order out of the 24 total options that we just counted. So our answer is D. Okay. Expected value. So anytime it asks about expected value, it says to multiply each possibility by the probability of its occurrence and then add all of those products together. So, and this one's kind of complicated, but we'll go through it together here. A game is played with a deck of 14 cards from a standard deck of playing cards. 2 cards have a 2, 3 cards have a 3, 4 cards have a 4, and 5 cards have a queen or a joker. 1 card is drawn at random, and the point value is equal to the number on the card, or 11 if the card is a queen or a joker. What is the expected value of P if random variable P represents the number of points on any one draw? So basically here, we need to figure out all of our options, all of the values, and the probability that goes along with that. Okay, so this is how we can write it. This is the notation we use. We need to first think about the value. So the first one, 2 cards have a 2. So the value there is 2. We need to then multiply that by the probability of drawing a 2. So 2 cards have a 2, so that means there's 2 out of the 14 total cards. Okay, then we move on to the 3s. Now for each one of these, we're going to be adding what we get together. So the next option is getting a 3. Okay, 3 cards have a 3, so the probability would be 3 out of 14. Next one is getting a 4. They said 4 out of the 14 are worth 4. Next is 5, so same type of thing here. Except that with the 5s, so it says 5 cards have a queen or a joker. The queen or a joker represents 11 points. So the point total there is 11, and there are 5 cards out of that 14. So this is how you find the expected value. Take each value times its probability and add all of those up. Okay. When you do that, and I would just use a calculator here, you're going to get 6. So kind of what this is saying is if you draw 1 card at random, the average or the expected value that you would get is a 6. Now, I know it's not possible to get exactly a 6. You can only get a 2, a 3, a 4, or an 11. But this kind of is looking at the average. Okay. Looking at patterns. Remember that we've talked about the difference between arithmetic and geometric sequences, right? If it's an arithmetic sequence, there's a common a constant difference. And then with geometric, it's a constant ratio. With arithmetic, you're adding or subtracting. With geometric, you're multiplying or dividing. On Monday morning, there were 60 cans of crushed tomatoes in a restaurant kitchen. On Tuesday morning, there were 53 cans. Wednesday, 46. If the number of cans used each day remains constant and no new cans are purchased, how many cans of crushed tomatoes will remain in the kitchen on Saturday morning? So I think this one is just as simple as finding your pattern here and then just continuing with it to get to Saturday. So it says there are 60, 53, 46. So then we need to figure out our pattern, okay? It looks like we're subtracting 7 each time. So we're just going to go ahead and continue with that pattern. To get an answer of 25 for Saturday. Okay. Next one, which pair of numbers can be inserted into the blank so that the ratio between adjacent numbers is constant? When you see that word ratio, you should think that you are multiplying here. Okay, so this one is really just kind of PETA, plugging in the answers and see which one works. Usually with that, we start with the middle, but here I don't think it really matters because you're just trying to see which one works. So it ends up being A, 6 and then 12. If you plug those in, then you can see here you're multiplying by 2, again by 2, and by 2 to get your next number. Okay, 52. A sequence is defined as, and then it gives you your equation for all positive values. If A sub 2 is 15, what is A sub 5? So let's start, they tell us A sub 2 is equal to 15. Let's go ahead, we need to kind of go in order here to get up to A sub 5. So for A sub 3, and I'm just using my formula here, I'll have 3 and then parentheses. So this is A sub n minus 1. Here n is 3, so 3 minus 1 would be 2. Minus 2 times, and then again n we said was 3 here, which is 3 times. A sub 2 is 15. They told us that. Minus 6 here. So 15 minus 6 is 9, times 3 is 27. So A sub 3 is 27. So we need to find A sub 4. So we get 3 times, so this will be A sub 3, which we said was 27, minus 2 times n, which here is 4. So when we do the math there, we end up getting 57. And then one more time. A sub 5 is, so 3 times A sub 4, which we said was 57, minus 2 times 5. And when we do the math, we get 141. So that gives us our answer, which is H. Couple more here, charts and graphs. So we're going to be using this to do our last two problems. Okay, so I will read through the question and I'll come back so we can look at the chart. 22, which of the following years had the greatest increase in the number of packs of gum sold over the previous year? So we are just comparing this year to the one before it to see which one had the biggest increase, right? So we go back and look here. 1994 was the first one, so I'm just going to show you what I'm looking at. 1994 is here, so I want to compare this year to the one before it, so the 6.5 to the 8.8, so that first one there, so that was F, had a difference of 2.3. Okay. Next one was 1997, so I look here and compare it to the one before it, so that difference is 1.2. Next is 1999, so here difference is only 0.8. 2001, again look above, that's a difference of 0.9. And then the last one was 2003, look here, so comparing the 12.7 to the 11.6, which is 1.1. So the biggest difference would be F of 2.3, so the year 1994. Okay. And then looking at the last problem here. According to the reported year-end sales, Morris Mint accounted for 15% of all gum sales in the year 2000 in the United States. Approximately how many packs of gum were sold in the U.S. in 2000? Okay, so if we jump back here and use our table. So we need to look at the year 2000 to figure out how many packs were sold. So in 2000, it was 10.4. Remember, we're talking about millions. Okay, so I'm going to jump back here so I have some room to write. So it's saying that Morris Mint accounted for 15% of all gum sales in the year 2000. So that 10.4 million, and I'm going to go ahead and change that and write it like this instead of just 10.4. is equal to 15%, so 0.15 of the total amount. Okay, so 10.4 million is equal to 0.15 times x. So then all I need to do is divide this by 0.15, and that will give my answer here, okay, which is 70 million. So E. All right, guys, so that's it for the notes. That finishes up the word problem section of the math part. So go ahead and look back at the Google Classroom. For your homework assignment, I'm going to be creating another video where I go through the answers and kind of explain the answers to that homework set. Thanks.